Hey, hello there. So tonight I'm going to talk about the 249 group shifted strings. So for the question is as follows. Given a string, we can shift each of its letter to the letter's successive letter. For example, if we have ABC, we would transform that into BCD because B is the successive letter for A, C is the successive letter for B, and D is the successive letter for C. And we can do this, keep doing this shifting as a whole. I mean, shift the 3 letters at a time to which form as a sequence. So it's A, B, C, B, C, D, C, D, E, D, E, F, etc. And finally we get X, Y, Z. But it's not very clear at this time point what happens after Z. So the question is, given a list of strings which contain lowercase alphabets, we want to group all the strings that belongs to the same shifting sequence. So for ABC and BCD, XYZ, we definitely would want to return them as a group. So the input example, we have the example for this. The input for this example is ABC, BCD, AC, EF, XYZ, AZ, BA, A, and Z. It just so happened that all the 3-letter strings belong to the same sequence. All the lens 2 belong to the same group, and all the lens 1 strings belong to the same group. That's guaranteed because we can. It's A, B, C, D, E. 26 in total in there. That's guaranteed to be there. But for the lens 2, it's kind of interesting because AZ actually become BA. This example tells us there is a cycle there. So if we reach Z and we shifted that towards its successive, it's actually A. So we have a 26 cycle there. So since that we are dealing with the groupings, we want to basically just write a hash function so that the strings that should belong to the same group will be hashed into the same buckets. And if we have that function, we can just call that function on all these input strings, and they will be naturally dispatched to the right buckets. After that, we just go for each bucket and collect all those strings, and that will be okay. So the question really boils down to design a hash function that can identify the pattern of the input string here. So the pattern is basically the everything is produced from the very beginning string. So all we need to do is to kind of normalize the very beginning one, so that everyone else, if you do the same kind of normalization, it will become the same thing. So let's talk about. Let's actually pick a little bit difficult one. So we have a ACEF. So the what comes after that is let's just do a quick example. It's going to be B, that's what comes after A, and we have D, that's what comes after C, F, that's what successive to E, F, G, so the very last character is G. You'll notice that we shifted every character by 1. So I guess if we look at the index for those characters in the alphabets, it's let's say that we are dealing with 0 index. A is 1, C is 2, E is 4, and F is 5. Then we transform that into 1, 3, 5, 6. So you notice that if we just subtract a 1 from this thing, we can get and we can basically get this to 0, 2, 4, 5. And the thing that's after that, I don't even need to write out the string, but I think it's going to be 2, 4, 6, and 7. And if we normalize this by the very first the number of the very first character letter, it's going to be 0, 2, 4, 5. And in the case that when we have case like the very first character is 5, but after that it's actually smaller than it. We can just do a modular to get that back to, you know, to get that working again. Yeah, you know, in the case of a rear end towards the late, maybe we can have like 25 in the beginning, and what's after that, it's after one cycle that becomes 1 and 3, and actually use a comma here, and 4. So when we do the normalization, we subtract the 1, subtract the 25 from 1, we get negative 24. But if we modular that by 26, we actually get, so let me actually do the diff. So it's 0, negative 24, negative 22, and negative 21. If we apply modular by 26, we get this to become 0, 2, 4, 5 again. So we basically deciphered this relator sequence string in the sequence to convert it back to to normalize back to the base case here. So the function, the hash function, is basically to get this normalized numbers that indicating the pattern of the you know, normalize the pattern of the string. So then we just use that hash function to find the buckets every string belongs to, and in the end we just go for all the buckets and return those buckets as a whole. So that's pretty much the strategy. So I'm gonna code this up. I'm just gonna call this hash function, and so for every character in the string, we're gonna do a diff with the first character and then modular by 26. That's the number for that location. And in the end, we just for how many characters we have in the string, we're just gonna use how many numbers and return that as a tuple. So that will be now key to that will be in our hash value, so that we can find the buckets. So I'm just gonna return the tuple of the character, the odd of the character minus the of the very first character letter in the string. And in this example, this will just convert everything in the sequence to 0, comma 2, comma 4, comma 5. And yeah, I need to do a modular by 26. Yeah, so that's gonna be our key to the hash table. So I'm just gonna return the sorry, I'm actually gonna do the insert. Let me actually just call it group by. For the strings in the inputs, I'm just gonna use the hash function to find the bucket. And put the string into the bucket. And in the end, we just returned all the buckets. So that's the solution. Yeah. Let's try run it. Okay. Yeah. So it works, and it's quite fast. So that's it for today. Bye for now.